Right, okay, we're doing this electrolysis thingamabobby. So the way I like to put ideas in my head is like this. So what I do is I draw the external circuit, plus, minus, I draw the electrodes, yeah, you've got, and at this moment what I do is I panic. Positive is an anode, so this here is an anode. And negative is a cathode, so this is a cathode. So this plus is here, this minus is here. So electrons are flowing in the outside circuit and that carrying the charge. And now you've got where are we? Come on, let's just do that actually. So let's label all these up. Let's get that. So the liquid there is the electrolyte. Let's spell that electrolyte. So this is the solution that's going to undergo the change. So this is the solution where the change is going to happen. Right, then we've got them two. They are called, oh my god, did I just second electrodes. We're going to pass electricity through them. Right, and they're normally, well, how can we write this one green? They are normally made out of carbon or something unreactive, or you'll see all these words going up. We've got positive anode, negative cathode. You've got your, this is direct current supply. You'll do this in physics. That you'll do in physics, direct current supply. I think that's it. That's the structure. If you can lay that structure out, you're on your way. Right, let's move on. Now, what they've done is they've presented this upside down. What I normally do. But we can still do the same thing. Right, what I'm going to do is that's aqueous sodium chloride. I'm going to come back to that. Let's do the malt. If there's a molten one, aqueous. If there's something molten, no, aqueous. Where's the there you go. Right, molten. So the reason I want to start with this, these are easier. Once you've got your head around this, the aqueous is slightly more involved, but if you can get your head around this, so what you've got in here, let's just ignore this word, right? Well, actually, let's do it here. I have got here lead bromide. Let's just say I've got lead bromide, solid, and it carries on forever all the way across, yeah? Just say that's lead bromide. Lead bromide is an ionic substance. Why is it ionic? Because you've got a metal plus a non-metal. So you're going to have lead to bromide. So that's what you've got. Look, watch this. I'm putting these here just to remind me which ions they are. So that's lead to bromide. Now if that's molten, just say I've got the one here, so I've got this. Plus minus. So what's going to happen is electrons are going to flow. That's your lamp. Electrons are going to flow. Really, they'll flow this way. That's the actual flow. Conventional flow was that way. So they're going to flow that way. They're going to come here, and there's nothing to carry the charge across here. So it'll stop. So this will be off. It will be unlit. It won't be lit up. Right. When you make it molten, you turn it into a liquid. So now these ions are free to flow, and they can carry the charge across there. And then that will then turn on, because you've now got a complete circuit and things are flowing round and round. Once you've got that idea, you're alright. Okay. So the student records the following observation. A small blob of silvery liquid, so it's most likely to be lead at one electrode. A dark brown substance appears on that. So bromine is a, well, I've said that I better not put dark. Just stick to what they've given. Brown substance. So that means bromine has got a brown color. I suppose you can say fluorine, chlorine, diatomic bromine, diatomic iodine, diatomic U, greedy, red brown fox wearing orange, Ivy's jacket, jumping over a grey fence, chasing a purple chicken. So that is gas, gas, liquid, solid, vapor, vapor. So bromine is, we know it as red brown, but you can write it down as brown. You can even put, yeah. Right, the lamp stops working after the teacher stops heating the lead bromide, because this then becomes solid. When it becomes solid, there's nothing to carry the charge across that gap. Nothing to carry the charge. So electrons flow here and ions flow here. Once the ions stop flowing, they're just vibrating apart around a fixed point. Right. Which is the correct statement about the electrolysis? The brown substances. No, that's bromine. The products are both elements here. Silver liquid is here. That's not true. We're expecting lead to go at the negative electrode, so that's not true. So we figured this out just from there. Actually, do you know what's the first part of the question? That's aqueous. Will come. Yeah, that's another question. That's preparing salt. Not interested, right? We can actually cross that out. What they're saying here. Okay. Uh, right. If you notice, last thing here. If you notice, ooh, that's a negative. That means it's got extra, not less, extra electrons. So we don't need to add 2 electrons. We really need to take them away. So this should be on this side. So we should really have, we can say electrons should be on product side, just to make it clear. What they could have done, they could have put -2, right? So that's the first thing, right? And second thing, and it's always good to know this, remember what I said to you, fluorine, really, did I just do that? Fluorine, chlorine, bromine, iodine. They are diatomic, they run around in pairs. So when bromine is formed, that too should be there. This should be here. Now it balances out. So 2Br should be Br2. Okay, so electrons should be on the product side, bromine should be Br2, and that's what it should look like. Last one, right? So remember what we said to, it was up here, for electricity to flow fully, you need something to carry the charge, and because now it's solid, it won't. So we need to write that down. We can write ions stop moving. You can say the ions stop moving, so there's nothing to carry the charge, yeah? Or, yeah, I think that's probably the most realistic way. And because ions stop moving, the electrons in the wires and the circuit outside also start moving. It's the same thing, that leads to that, but in this case that's probably the best answer. Right, let's look at this one. Nope. So you've got the same idea. If it's molten, molten's a bit easier to do. Right, the teacher's going to use this operator. So you've got your battery or your power source. You've got your lamp to show that things are flowing as a complete circuit. You've got molten metal. No, let me rephrase that. Molten ionic compound. You've got your negative electrode, positive electrode. I can never remember, so I panic at this stage. So no, positive is anode. So I know this will be an anode. So the negative is a cathode. So I know that will be a cathode. Right. They're applying heat and it's molten. So because ions 2+ and chloride ion, because ions are free to move, they'll carry the charge and you'll get a full circuit and that will light up. Right, now they've said, like in that previous example, crystals of shiny grey solid will form at one of the electrodes, and it's going to be here because there's a negative electrode, that's a positive ion, and that solid grey shiny material will be zinc, and a pale green substance here, that'll be chlorine. The lamp goes out after the teacher stops heating the zinc chloride. That's because this becomes a solid, and all the ions do, they vibrate about a fixed position. Right. Oh, what is electrolysis? Now this is a key one. You need to learn this, so just make a note of that and sit down and learn it. So it's the breakdown or decomposition, the breakdown of a compound using electricity. So 2 points. You're going to put them in one sentence, but right, state why graphite is more suitable than magnesium in this electrolysis. Because magnesium will react or reacts with chlorine. So excuse the capitals in the middle of a sentence. Right. Which of these is a correct statement? It's not chloride, it's chlorine. Both are elements. That's interesting. It's almost a carbon copy of that previous question. Right. Oh, okay. Same idea. This negative charge indicates that you've got extra electrons, because you've got an extra minus there. So this 2 plus should be on that side. And what did we say about fluorine, chlorine, bromine, iodine? Yeah, it's what type of molecule? Diatomic. They run around in twos or pairs. Yeah. So we can say, what can we say? Let's have a look. Okay, right, there's two ways of answering this. We can say it should be minus 2 electrons, or we can say it should be on the other side of the equation, or the right hand side. Yeah. And the other one is the 2Cl should be Cl2. That's probably the clearest way to do it. Why does the lamp go out? Why are electrons no longer flowing through the wires? Is because the ions in the electrolyte, ions can not flow, so no loss of electrons take place. It's the flow of electrons that'll give you your flow of electricity. Okay, here number 12, same idea. Same idea, right? You've got magnesium chloride, and it needs to be melted, so it's molten, right? And why do we need to make sure that magnesium, so remember magnesium chloride is an ionic compound, Why is it magnesium? Why is it an ionic compound? It's because, that's a good question, because you have a metal reacting with a non-metal. Right, so we've got ions there. Magnesium chloride has to be melted because the ions need to be able to flow in a solid. The ions cannot flow but can flow when molten or liquid. Yeah. Right. So how do we form magnesium? So we had a magnesium 2 ion. Now that plus there tells you that we have 2 less electrons. So we need to add 2 electrons to give us a magnesium atom. Right, they're saying, why would you not use steel? Again, you've just got to learn this because steel will react with chlorine. Chlorine reacts with everything. Very naughty. Okay, that's the last one for this. Right, now the rest will be aqueous solution. So what we need to do is go right to the top and start again. Right, so what I'm going to do is in the next video I'll try to explain it here and then we'll go down and start tackling those.